built-in functional interfaces and method references. So we have these 4 core interfaces: predicate, function, consumer, supplier. We will discuss those 4 and their types. Those were derived from these 4. Okay. And we have more than 40 overall, if we can say. We can think of these 4 as like shapes of behaviors. First one is predicate. Its abstract method is test. Okay. Purpose, test a condition. Signature T, like any type, and return type is boolean. So this one takes something, returns boolean. Something like, does this thing satisfy condition or anything? Okay. Then we have function that takes something and returns something else. Okay. So its method is apply and signature is this one. Then we have consumer and supplier. So why don't just we see these two in our code? In this one, external libraries, you can open or you can see. So you can see many modules. We have to open this one, java.base. In this one, you can see in Java, we have many packages. In util package, you can find another package that is function. Okay. So in this function, you can see we have so many interfaces. We have by consumer, by function. So this one is consumer. You can open this one. So in this one, you can see its abstract method is accept. Okay. Consumer. Okay. This one. Consume input side effect. Okay. Return type is void. You can also see function. Okay. Apply. Return type is your second argument type. And you can also see supplier, predicate. Okay. And others are just derived from these 4, like double predicate, double supplier, double consumer, double binary operator. We will see by predicate. All right. Now let's see our first one. String. This one, s dot length greater than 3. We can test this one. Or maybe first we can just create and then we can test predicate s dot is empty. Let's take this one. We can create for some integers. Integer, we can say predicate 3. Okay. So now we can use those on test hello. Okay. So you can see we can now use those, compile, just run this one. So you can see we got true in all cases. So first one, length greater than 3, yes. We have here 5 is empty, yes. I greater than 3, yes. Let's pass here 2 and let's put here anything. Now if we compile and if we run this one, so we got false in these 2 cases. So just simple thing. But we also have some composition in this one, and that we will see. Predicate testing conditions, predicate composition. Predicates can be combined using and, or, and negate. And you will also see this one here as well. Okay, so predicate.java, you can see here we have negate or is equal. So we have some static methods, not, okay. But we have only one abstract method, okay. We have some static and some default methods as well. So now how we can use those? Okay, so we can combine here. Let's say we want to combine our negate with this one is empty. Okay, this one. So with predicate 2, how we can do that? Okay, so we got one suggestion, that is predicate.and predicate 2. Length should be greater than 3 and this one should not be empty. Okay, so here we combine 2 predicates and that's fine. Now we can also create with or, that's also fine. We can also do something predicate, let's say 2 dot. Okay, so we are getting one suggestion negate. This will return true if we have empty string, and this will return true if we have something. Okay, not empty. And we can test this one. So compile, run this one. So in this case, we got true. So for this one, we got false. Okay. So this is some composition for predicates. Okay. And we also got one factory method in later part of our Java, some 11, this one. Combine predicates, real world. Okay. So static helper, predicate.not, Java 11 added this one for cleaner negation. So before Java 11, we were doing something like this, and this one is kind of awkward, like negating a method reference. Okay. So we have this one cleaner approach, predicate.not, string is empty. Okay. Okay, now next one we have function, transforming values. Takes input of type T and returns output of type R. It's the core transformation interface. Okay. So you can see some practice here. Okay, length. This one we will take string, we will convert, we will return integer, and that will be its length. So we can do some practice. Okay. Now we can see some function composition, chain functions with and then and compose. You can see here. For function, we have compose and then. Okay. We have one static that is identity. So returns a function that always returns its input argument, identity basically. We will see its example, but let's see first those two, compose and then. Here we can write function, let's say length equals to, we can use method reference or we can go directly with this one, s dot length. Okay. We can import this. Method reference we can replace. Okay, let's see. Because we will see method reference in this chapter. So why don't we just practice? Okay, so we have to remove this one, right? So that's fine. And then we can also create one another like function that will take integer as input and will return, okay, let's say integer. We will return double whatever length we have here. Right. And here what we can do, we can also create one another functional interface that will be, so here we can combine. Now what we can do is we can combine these two. That will be, okay, so we are getting one solution. Let's take that. So it will be length on this one dot and then double length. First we will use this one and its output we will pass to this one. Okay. So basically first we will handle this one and on this one we'll call this method and inside that we have this function interface. Okay. Now we can call, so length and double dot apply. Let's see. So we should get 10 now. Okay. Compile this and just run this. Okay, so we got 25. Okay, so we have here multiplication, not addition. Okay, so that's completely fine. And if we put here plus, this time we will get 10. Okay. Now we can move forward. Apply that first, then this identity function. So function.identity returns its input unchanged, useful as a default or placeholder, like this one. Function.identity. So identity.apply, and you can see useful in collectors. We will see this one later. So this one is just do nothing function. Now let's say consumer side effects takes input and returns nothing. Import this one and then We can pass here string and we can just print this or anything, just we don't have to return anything. Okay. Now you can see we can also have consumer chaining here, chain multiple side effects with and then. Okay. So execute all three in sequence. First we have this one, log, save, notify, print statement here. Here we have some write, not print statement. Then we have something this send. Don't copy this code and just run this one because we don't have these things. Okay. Just this one is just for understanding. Let's say we have one service, email service method or class or instance. Then we can call this one. Consumer, we have this full process. So log dot and then we can call this save. Then we can call this one notify. Okay. Okay. So we require input in this one for consumer. And we have this dot and then. So we will pass same string. Okay, that we will call in the first one, full process dot accept. So we will pass this method in all of these. Okay, same thing. Common use case, let's say for age, you can see. Now next one we have supplier, producing values. Takes nothing and returns a value, perfect for lazy evaluation and factories. We can see supplier, then we can do here double random. Okay, we can also do this, or this one is short syntax. We can also do this one, math.random. And now we will see one suggestion from our IDE. Lambda can be replaced with method reference. So that's fine. We don't have to call this one. We can just first create our suppliers. Supplier double random 2. Okay. Timestamp equals to, we can put here system dot. So we got one suggestion. Let's take this. Okay, what is this? Okay, so we can do here long. Now we can also do some, let's say, list of string. Now we can use, so we got one suggestion, random.get. So we have this get abstract method in case of suppliers. You can see, okay. And run this one. So we got something, okay. Okay, now we can move forward. Lazy evaluation with supplier. So this one is important. Suppliers enable lazy computation. The value isn't computed until get is called. Let's say we have one expensive computation wrapped in supplier. So supplier expensive object, lazy loader, okay, computing, return new expensive object, only created when get called. So if you just write this one, nothing will happen. Okay, later if needed, if condition, now you can call and now this one will be computed. Okay. Another option for that is or else get. Okay. So or else we can see default value computed even if not needed. So optional we have. So don't run this one directly. Okay. First you need to create instance for this one. All right. So optional dot or else, but we have same thing here, optional dot or else get. Okay, so that's fine. Maybe we can see this one. Okay. Okay, so first let's create this one, string optional dot of hello, and now we can say result one optional dot or else. So if we do not print this one, and we can create another way, that is optional dot or else. Rather than having just a simple string value, here we can have any, like let's say function, right? So if we just do this one, then this one will be evaluated even we are not using this. Okay. Or if our hello is present. All right. So in this case, this one will be executed if our hello is present or not present, doesn't matter. So we can stop this one. by using this our suppliers way. And here we can call this expensive function. Okay. Okay. Now next one is bivariants, 2-argument versions. For operations needing 2 inputs, Java provides biversions. So for by predicate, okay, test tu, boolean will be returned. So for by predicate, if we need 2 inputs, then we can do that. We can use this one for BiFunction. So if we need 2 input and we need 1 output, then we can use this. Same for by consumer. Okay. So they also have same implementations, just derived from this. Now we have operator interfaces. So operators are specialized functions where input and output types are the same. For unary operator, we have this function with same input and output type. For binary operator, we have, let's say, all same types. So method references are shorthand for lambdas that simply call an existing method. Okay, they use this operator, double colon. Okay. Now 4 types of method references. First one is static method reference. First is class name, then static method. So let's say we have this lambda function and as integer.parseInt. So here we have this class name integer, and in this one we have one static method parseInt. So we can call directly this, and our compiler will match, okay, this syntax. So we call this one static method reference for any class. Then we have instance method on a specific object. Let's say you have one instance reference. So for this one is one instance, right? Prefix. Let's say you want to concat in this one something, dot concat as, you can do directly this one, prefix and then concat. We have this method in our string plus. If you open this one, so we have this method here. Okay, and this one will be your instance method. This is not any static or default. Okay. Now third one, we have instance method on parameter object. This one is a little bit tricky. Let's say we have this lambda. We will take string, we will return its uppercase. So method reference, what we can do. First thing is class name, then instance method. The first parameter becomes this. So first parameter is, let's say, a string, then string to uppercase. So this one will be called on whatever string the function receive. Okay. Constructor reference, class name, then new. So this is the lambda supplier that returns something and takes nothing. Okay. So constructor reference we can do. So on array list, this one is class name. We have this new. So new means we have constructor. If you copy this one, then you will see we will get in return array list of strings. So we have this constructor reference here. Method reference conversion table. So instance on object, instance on parameter, you can see. So our compiler will figure out just one by one. If anyone match, then we are good. Then we have primitive specializations. So to avoid boxing overhead, Java provides some primitive specialized versions. Okay, like int predicate, is even, int function, consumer, supplier, like that. Okay, also we have long predicate, double function, into double function. Now performance step, when working with primitives and streams, use these ones. Okay, and they are specialized functional interfaces to avoid auto boxing overhead. So quick reference, test a condition, predicate, test with 2 inputs, by predicate, transform function, 2 inputs, by function. So you can see. Now we can see our quick summary part and we can move forward with our next chapter, which is introduction to streams.